Have you ever stopped to ponder the unseen forces that shape our world? The invisible threads that weave the fabric of our reality? We navigate our lives amidst a constant interplay of pushes and pulls, many of which we barely even notice, yet they are always there, guiding us. Gravity, for example, keeps our feet planted firmly on the ground, a constant companion we rarely acknowledge, yet it is always present, holding us close to Earth. But there's another force, equally pervasive yet often overlooked, that silently orchestrates a symphony of wonders around us. Magnetism, a force that is both mysterious and fascinating. From the intricate dance of electrons within our electronic devices, creating the technology we rely on every day, to the awe-inspiring spectacle of the aurora borealis painting the night sky with its ethereal glow, magnetic fields are the invisible architects of countless natural phenomena and technological marvels, shaping our world in ways we are only beginning to understand. They are the silent partners in our modern world, powering everything from electric motors to medical imaging devices, making our lives easier and more efficient. Yet, despite their ubiquity and importance, magnetic fields often remain shrouded in a veil of mystery, their true nature eluding the grasp of casual observation, leaving us to wonder. In this exploration of the magnetic realm, we embark on a journey to unravel the secrets of these enigmatic forces, seeking to understand their essence. We delve into their fundamental properties, seeking to understand their origins, their behavior, and their profound impact on our lives, both seen and unseen. Get ready to have your perception of the world transformed as we illuminate the invisible forces that bind our universe together, revealing the hidden beauty of magnetism. Our journey begins with a fundamental question. What exactly are magnetic fields, and how do they influence everything around us? How do they arise, and what makes them so influential in the grand scheme of things, affecting both the smallest particles and the largest celestial bodies? Fasten your seatbelts, for we are about to embark on an exhilarating adventure into the heart of magnetism, a journey that promises to be both enlightening and thrilling. Imagine a world without the invisible hand of magnetism guiding our compasses, powering our cities, and enabling the very technology we rely upon. It's a world we can scarcely fathom, for magnetic fields are so deeply intertwined with the fabric of our existence that their absence would unravel the very essence of modern life as we know it. From the moment you wake up to the time you lay your head down to rest, magnetic fields are tirelessly at work, silently shaping your every interaction with the world around you. The gentle hum of your refrigerator, the crisp sound emanating from your headphones, the smooth acceleration of your car, all these everyday experiences and countless others are orchestrated by the invisible hand of magnetism. In the vast expanse of space, magnetic fields sculpt the cosmos on a grand scale, influencing the birth, life, and death of stars. They shield our planet from harmful cosmic radiation, creating a protective bubble that has nurtured life for billions of years. Here on Earth, they guide migrating birds, empower our navigation systems, and even leave their imprint in the very rocks beneath our feet. Join us as we embark on a captivating journey into the realm of magnetic fields, exploring their profound influence on our planet, our technology, and our lives. Prepare to be amazed by the unseen forces that shape our world.
Section 4. Defining the force. What are magnetic fields? Imagine an invisible force field, a kind of magnetic aura surrounding every magnet and flowing electric current. This force field is not something we can see with our eyes, but its effects are very real and observable. This aura, my friends, is what we call a magnetic field. It is a fundamental aspect of electromagnetism, one of the four fundamental forces of nature. It's a region of space where magnetic forces can be detected, influencing the behavior of other magnets, magnetic materials, and even moving electric charges. These interactions are crucial in many aspects of our daily lives. Now, these magnetic fields aren't just random and chaotic. They have a distinct structure and direction. This structured nature allows us to predict and understand how they will interact with other objects. We can visualize them as lines of force called magnetic field lines that emanate from the north pole of a magnet and curve gracefully towards its south pole. These lines provide a visual representation of the field's direction and strength. These lines, though invisible to the naked eye, represent the direction in which a compass needle would align itself at any given point within the field. This alignment is a practical demonstration of the field's influence. The strength of a magnetic field is not uniform. It's strongest at the poles of a magnet, where the field lines are most concentrated, and weakens as you move away from the poles. This variation in strength is a key characteristic of magnetic fields. Think of it like the gravitational pull of a planet, which is strongest at its surface and diminishes with distance. Similarly, the magnetic field's influence decreases as you move further from the source. These magnetic fields are more than just theoretical constructs. They are powerful forces that shape our world in countless ways. Their influence extends from the smallest particles to the largest celestial bodies, from the majestic aurora borealis illuminating the polar skies to the intricate workings of our electronic devices. Magnetic fields are the unseen architects of a remarkable array of natural phenomena and technological marvels. Their impact is both profound and far-reaching, touching many aspects of our lives.
Section 5. Visualizing the invisible magnetic field lines. While we can't see magnetic fields directly, we can visualize them through the elegant concept of magnetic field lines. These lines, often depicted as graceful curves emanating from the north pole of a magnet and converging towards its south pole, provide a powerful tool for understanding the behavior of magnetic fields. Imagine sprinkling iron filings around a bar magnet. You'd witness a fascinating phenomenon. The filings wouldn't scatter randomly, but would arrange themselves in a distinct pattern, forming lines that trace out the magnetic field lines. This simple experiment offers a tangible glimpse into the invisible world of magnetism, revealing the structure and direction of the magnetic field. Each magnetic field line represents the path a tiny compass needle would take if placed at that point in the field. The lines never cross, and their density reflects the strength of the magnetic field, with more closely spaced lines indicating a stronger field. These magnetic field lines aren't just theoretical constructs. They provide a powerful tool for predicting how magnets will interact with each other and with magnetic materials. They help us understand why opposite poles attract and like poles repel, and they are instrumental in designing and optimizing a wide range of technologies, from electric motors to magnetic resonance imaging (MRI) machines.
Section 6, North and South, Understanding Magnetic Poles. Every magnet, whether it's a simple bar magnet or the Earth itself, possesses two distinct poles, a north pole and a south pole. These poles are fundamental to the magnet's properties and behavior. These poles are not merely geographical designations, but represent regions of concentrated magnetic influence, where the magnetic field lines converge or diverge. This concentration of magnetic force is what gives magnets their unique properties. The north pole of a magnet is defined as the pole that seeks or points towards the Earth's geographic north pole. This is a crucial aspect of how compasses work. Conversely, the south pole of a magnet points towards the Earth's geographic south pole. This alignment is essential for navigation and understanding Earth's magnetic field. This seemingly counterintuitive naming convention arises from the fact that opposite magnetic poles attract each other. This attraction is a fundamental principle of magnetism. Therefore, the Earth's geographic north pole actually houses a magnetic south pole, while its geographic south pole harbors a magnetic north pole. This reversal is a fascinating aspect of Earth's magnetism. Magnetic poles always exist in pairs. You can't have a north pole without a south pole. This pairing is known as a magnetic dipole. This fundamental principle, known as magnetic dipole, is a consequence of the way magnetic fields are generated by moving electric charges. The movement of these charges creates the magnetic field. Just as every positive electric charge has a corresponding negative charge, every north magnetic pole is eternally bound to its south pole counterpart. This inseparable nature is key to understanding magnetism. The interaction between magnetic poles governs the behavior of magnets. This interaction is what makes magnets so useful in various applications. Opposite poles, such as a north pole and a south pole, attract each other, while like poles, such as two north poles or two south poles, repel each other. This repulsion and attraction are fundamental to magnetic interactions. This fundamental principle forms the basis for countless magnetic phenomena, from the simple compass needle pointing north to the complex interactions within electric motors and generators. These devices rely on the principles of magnetism to function effectively.